Many students have a hard time with pulleys and how they work. What we know about them this far in statics is, first, they are frictionless. Second, that they transfer forces equally from one end to the other of the pulley. And when they are used in systems, they can be used to gain mechanical advantage. This means that if you have several pulleys used either in series or in parallel, they can lift a lot more than what you originally pull on them. This is a small example of a pulley system. As you may notice, there are pulleys that are in series and in parallel. When a pulley is in parallel, it will transfer the force equally along its groove. While a pulley is in series, it will feel a combination of the tensions pulled along the groove. Let's draw a free body diagram for each pulley to see what forces they feel. First, to draw the free body diagram for each pulley, we have to cut the ropes with our imagination and see what forces will be going in each direction. Then we can add in each of the forces and follow the rules for pulleys. Force F will transfer equally from one end of pulley B to the other, and the same can be said for pulley A since it is in the same rope. Now that we can see that the pulleys in parallel are maintaining the same tension, then pulleys in series will feel a different force, which we will label as T1 for now. Next, I'll add in any other forces that are felt by the pulleys. T2 is the force that the pulley C exerts on the ceiling, and W is the weight on pulley A. Now we can look at each pulley. I'll start with pulley B this time by summing forces in the y direction. Observing that T1 is equal to 2F, we can take that over to pulley C. And looking at pulley C, we can notice that T2 is equal to 2 T1 forces, or 4 F forces. Finally, we can end with pulley A, and notice how there are 2 F forces and 1 T1 force. We can then sum forces in the y direction and use substitution to find that our weight is equal to 4F. That means that if we pull with 1 pound of force at pulley B, then we will be able to lift up to 4 pounds of force at pulley A. I made this example problem using a diagram that is similar to one of the problems you have in class, but I tweaked it a little bit to help understand the pulley relationship and to also make sure that you yourselves work on the problems that you have in class. In this problem, we are given the mass of E, which is 30 kilograms, and the maximum tension of cable BA, which is 300 newtons. We're then asked to find the maximum mass of D and also the angle theta required for that maximum mass. For this problem, we'll have to assume that cable BA is at max tension. So whenever I look at any problem, I always like to make a plan before I attack it. So I'll start with the basics of making a free body diagram, and then after that I'll label my forces. Simplify any way I can will usually help me understand the problem a little bit easier, and then I'll start summing forces in the x and the y directions. Well, first here's my free body diagram of point B. Without labeling any forces yet, it's pretty simple, which is what we want in a free body diagram. Next we'll put some more information on there, which is adding the forces of cable BA and the mass of E. Now, since it's a mass, we need to get that into forces, so we usually have to multiply it by gravity to get our force in newtons, and we get 294.3 newtons. Now, with tension BC, we usually have certain problems with that, not knowing that theta. It often makes it very difficult, and we have to use trig identities, and I know a lot of students don't particularly care for trigonometry too much. You could always try to figure it out using sine of theta and cosine of theta, but sometimes I find it easier to use Pythagorean Theorem. I usually will draw in a TBCY and a TBCX force that represent the x and y components of the tension. That creates a triangle, which means that the square root of the sum of the squares of those two forces will equal our tension BC. Sometimes it makes it simpler to deal with, sometimes it doesn't. But I would rather have a tool bag full of tools of diverse methods of solving problems than just one tool. With my free body diagram drawn, my forces labeled, and simplified as much as I can, I'll now begin the calculations. I'll start by summing forces in the x and in the y directions, which will give me my TBCx and TBCy. TBCx equaling 300 newtons and TBCy equaling 294.3 newtons. Using Pythagorean Theorem, I can find that TBC is equal to 420.25 newtons. And by using the arc tangent, I'm able to find that angle of theta, which is 44.45 degrees. I know that tangent of theta is equal to my opposite leg over my adjacent leg of the triangle. So that would be the TBCy over the TBCx, and then I just take arc tangent of that. Now that we have figured out what the tension is in cable BC, we can bring that to our other free body diagram, which is of the pulley. Since we know that forces are transferred equally from one end to the other, we can go ahead and say that both those forces are equal to 420.25. Knowing the tension in the cable that is connected to mass D makes this problem really easy all of a sudden, because all we have to do is take that mass and that force and divide it by gravity, which is 9.81, and we get our mass of 42.84 kilograms. So now we've found all of our answers, which is a theta of 44.45 degrees, and our mass, which is a mass of 42.84 kilograms.